Okay, we're going to graph radical functions, and I'm going to start by looking at how the 5 affects the parent function. So what I'm going to start with is just a sort of t-table of my parent function. And that will be a nice thing to look at if I have x and y. If x is 0, y is 0, 1, 1. If x is 2, I'll do 4, excuse me. If x is 4, y is 2, and x is 9, y is 3. Okay, so the parent function has this t-table. This is just for y equals the square root of x. And what I'm going to do is say, well, I know that this guy right here, this plus 5, is telling me that it's moving up 5. So I'm going to take my parent function, and it would normally be starting here, but it's going to move up 5. So it's going to move up 1, 2, 3, 4, 5. So I'm going to start it here. I'm going to erase all this. This is really where I'm starting my function. And if I treat this beginning of my function here, 1, 2, 3, 4, 5, as if it's the 0, 0, I can use all of this table to build the rest of my graph. So if this was 0, 0, then I would move over 1 up 1. This would be 1, 1. And if this were 0, 0 and this were 1, 1, then I'd move over 1, 2, 3, 4 and up 2. And then I could move over 5, 6, 7, 8, 9 and up 3. I just have moved the entire thing up 5 spaces, and I just draw the graph as if I always like I always do. I just have moved it 5 spaces above the origin. When I do this, I can say that my domain is where does it live this direction. So all my x's start at 0 and go out forever. So I can say that my domain is all of my x's are bigger than or equal to 0. And then my range is it's starting here at 5 and going up forever. It's going out, but it's also going up. So I can say that my range is all my y's are bigger than or equal to 5, and that my vertex here, this guy has moved from 0, 0. He's now at x is 0 and y is 5. Okay, so that's how I'm going to do these things. I'm going to do the whole thing by using this standard t-table right here. I'm going to kind of reference this the whole time. And I'm going to do the next problem. When I'm doing this one, I can say that I know that it's moving this way 1, and then it's going to move this way 4. So I'm going to take my parent function, and I'm going to move it to the right 1 and then down 4. So I'm going to move right 1 and down 1, 2, 3, 4. That's going to be where my 0, 0 is. And then I'm going to go back to this table right here and say, well, if this is 0, 0, then I could start counting from there and say, well, this would be 1, 1, and this would be 1, 2, 3, 4, 1, 2, and this would be 4, 5, 6, 7, 8, 9, up 3. So if I'm just counting from that original one as if it were the origin, I can draw in my graph, and I can find my domain and range. So from here, I say all of my x's are going this way, right? They start at where x is 1 and get bigger. So all my x's are bigger than or equal to 1. And then all my y's, well, they start here, down here at negative 4. And then they're going out, but they're also going up forever. So I can say all my y's start at negative 4. They're all going to be bigger than or equal to negative 4. And that vertex is no longer at 0, 0. It's moved down here to where x is 1 and y is negative 4. So I'll write that x is 1 and y is negative 4. Okay, and I'm going to do this one with you. We're going to use this table. I'm going to write it again so I don't have to move my screen. But when I have my x and my y, I've got 0, 0. When x is 1, y is 1. When x is 4, 2, 9, 3. and this is for my y equals the square root of x. But I know that it's moved this way 1. So I'm no longer at 0, 0. This 0, 0 is now moved over 1, so I can say that this is now at this place. But I also have this stretch here of 3, which means all of my y's are multiplied by 3. So if I take all of my y values here and I say that I'm going to say this right here, really am getting frustrated. Okay, I'm going to say that I'm going to make another value here for my y's and say I'm going to take every single one of these values and multiply it by 3. So 3 times y is really 0, 3, 6, and 9. So 0 times 3 is 0, 1 times 3 is 3, 2 times 3 is 6, and 3 times 3 is 9. So I will use 0, 0, 1, 3, 4, 6, and 9, 9 as my points to stretch my graph. And I'm going to say if this space right here, if this is my origin, if this is 0, 0, then I can count from here and say, well, what would 1, 3 look like? So I would move over 1 and up 1, 2, 3. So that would be 1, 3, and 4, 6 would be 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. That would be here. And then 9 would be 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 here. And then I could draw in my graph like this. All right. So I'm going to find my domain and my range. My domain is all my x's. My x's start here and they're going this way forever. So they're starting at -1 and they're going on forever. So my x's are bigger than or equal to -1. My y's are starting at y equals 0. They're going up forever. They're going this way, but they're also going up. And so I can say that all my y's are bigger than or equal to 0. And the vertex has moved over. This guy right here is moved from the origin of 0, 0. And I can say that's going to be where x is -1 and y is 0.